Hi everyone. There are some ways to integrate functions. One of them is integration by parts. This method is based on the product rule of differentiation. I think you are all remembering this formula. Derivative of f times g is equal to derivative of first component times second plus first times derivative of second. Or if you make this term alone, you have f g prime is equal to f times g prime minus f prime g. Integrating this equality with respect to x, we get integral of f g prime dx, of course, integral of f g prime dx minus integral of f prime g dx. Okay, now it's possible to use fundamental theorem of integral to re-express this expression, this term. So we have integral of f g prime dx is equal to, instead of this, we have f times g minus integral f prime g dx. Let's say u is equal to f of x. Okay, I rename the functions, and v is equal to g of x. Okay, g of x. So in this case, du is equal to f prime of x dx, and dv becomes g prime of x dx. Okay, so if you use these new notations, this equality becomes integral u dv is equal to uv minus f prime dx. F prime dx becomes du, g is v du. How do we choose the function u? Whichever function comes first in the following list becomes u. Okay, if you have, for instance, logarithmic function in the integral, then you have to say u is that logarithm function. If you have an logarithmic function and an algebraic function like x cubed, then u becomes logarithmic function. Okay, let's look at the first example. Integral of x times sine x. So according to this list, we have an algebraic function which is a polynomial and a trigonometric function. According to this list, algebraic functions comes first. See, first algebraic, then trigonometric. So u must be x. Okay, u must be x. So if u is x, then du is dx, and the rest becomes dv, the rest, which is sine x dx, becomes dv. Okay, if you integrate both sides of this equality, you get v as minus cosine x. Okay, now let's use the formula of integration by parts and all this information. Okay, all this information in the formula, and continue to solve the problem. Then this integral is equal to, look at the formula, u times v, so it means minus x cosine x minus integral v du. V is minus cosine, minus plus integral of plus v du, v is cosine, du is dx, so we have plus cosine x dx. Okay, so the rest is just to solve this integral, this one. This is equal to minus x cosine x. What is the antiderivative of cosine x? Antiderivative of cosine x is sine x, so this is plus sine x plus a constant. Since it is an indeterminate integral, we must have a constant. This is the first example, the easy one. In the second example, we have again an algebraic function, which is a polynomial and an exponential function. Let's look at the list again. Which one comes first? First we have algebraic, then exponential. So u must be x. U must be algebraic function. U is x. In this case, again, du is dx. dv is the rest. dv is the rest. ex dx. So it means v, if you integrate both sides, v is equal to e to the power x. Okay, so using all this information, this integral is equal to, and using the formula of integration by parts, u times v x e to the power x minus v du, v du is dx. So this integral becomes x e to the power x minus antiderivative of exponential function is the exponential function itself. Since the integral is indeterminate, we must have a constant c. So the next example, ln x. It is also a famous question. What is the integral of ln x? As you see, we only have one function in the integrand, so we don't have algebraic, trigonometric, or exponential function here. So what is u in this case? Let's look at the list again. Logarithmic function comes first. As you see, we have 1 as a multiplication, 1 times ln x. So 1 is an algebraic function, but since logarithmic function comes first, u must be ln x, logarithmic function. So du is dx over x. If you integrate both sides, you have dx over x. So the rest is dv. The rest is dv. What is the rest? The rest is dx. So the rest is dv. If you integrate, you have v, which is x. So using the integration by parts formula, we have u times v x ln x minus integral v du dx over x. Okay, so if you continue, you have x ln x minus, cancelling these two terms, you have x plus c. If you wish, you can take the parentheses of x, then it becomes this. I think it's also clear. Let's look at another example. So we have now a more complicated question. Sin x ln of cosine x dx. So we have an ln function, as you see, we have an ln function and a trigonometric function. Okay, so since logarithmic function comes first, u must be logarithmic function ln cosine x. Okay, so u is ln cosine x. U is equal to ln cosine x. In this case, du is equal to, if you integrate both sides, derivative of inside over inside. Derivative of inside, derivative of cosine is minus sine x over inside cosine x. So this is equal to, as you see, minus tangent x. Of course we have dx here, okay, minus tangent x dx. So this is u du. What about dv? dv is the rest. The rest is sine x dx. In this case, if you integrate both sides of the equality, v becomes minus cosine x, since minus cosine x is the antiderivative of sine x. Okay, minus cosine x is the antiderivative of sine x. This is why v is minus cosine x. So let's go back to the integral and use the integration by parts formula. U times v from the formula minus cosine x ln cosine x minus v du, okay, from the formula v du. V is minus cosine x, du is sine x dx, let me look at the formula again. V du, yes, okay, v is minus cosine x and du is sine x dx. Okay, so it means, let me write down the integral v du minus becomes minus, okay, cosine x times tangent x, which is sine x over cosine x dx. This is v du, and this integral is equal to minus cosine x ln cosine x minus sine x, you cancel these two terms, sine x dx. Okay, if you wish, you may consider this minus here. And finally, the last step, to integrate this term, cosine x ln cosine x plus, what is the antiderivative of minus sine x? The antiderivative of minus sine x is cosine x. So cosine x plus c. This is the answer of this question. Let's continue to solve more problems. Arc sin x. The next question is arc sin x. Since we have 1 as an algebraic function and arc sin x, actually we have 1 as, let's go back to the list again. Inverse trigonometric functions comes first. See, inverse trigonometric functions comes first. So u is inverse trigonometric function arc sin x du. If you differentiate both sides, du is equal to derivative of arc sin x is 1 over square root of 1 minus x square dx. Okay, this is u du part. What about dv? dv is the rest, very easy. What is the rest? dv is dx. So v becomes x. So we have all information to use integration by parts formula. This integral becomes uv, u times v, x arc sin x minus integral v du. V is x, du is this expression, x dx and the square root of 1 minus x squared. Okay, so the question how do we integrate the last two? Okay, if we can integrate the green part, then we will complete the solution. As you see, using the substitution rule, it is not so difficult to integrate this term. Arc sine x minus plus, so it becomes square root of 1 minus x squared plus c. So how do we get square root of 1 minus x squared? So if you use substitution rule, for instance, if you say x squared is w, 2x dx in this case is dw, okay? If you use this substitution for this integral, then you will have square root of 1 minus x squared. So now I want to solve some definite integrals using the same technique, integration by parts. The first example is the integral of arctangent x from 0 to 1. Since we have an inverse trigonometric function, u becomes the inverse trigonometric function, since this comes first, arctangent x. So in this case, du, derivative of arctangent x is 1 over 1 plus x squared. So we have dx over 1 plus x squared. What about dv? dv is the rest, dv is the rest, dv is dx, and v is x. Okay, using all this information and the formula of integration by parts, we have this is equal to u times v x arc tangent x minus integral v du x dx 1 plus x squared. Again, if we use substitution rule for this problem, let's say we have 2 here, 1 over 2 here, okay, and say x squared is equal to w, so in this case 2x dx becomes dw. You will easily have the solution for the second integral. Finally, we have x times arc tangent x arctangent x, and finally, since 2x dx is dw, we have minus 1 over 2 dw over instead of x squared we have 1 plus w, okay, 1 plus w. As you see, I ignored the boundaries of integration. This is the first way, but of course it's possible to not ignore the boundaries of integration. Then I will also show this as a second way. Okay, let me first integrate the indefinite integral, then continue dw over 1 plus w. Then we have x arctangent x minus 1 over 2 ln 1 plus w plus c, of course, plus c. So as you see, I ignored the boundaries of integration. If you wish, you can now use these boundaries. Okay, now use these boundaries. Let me ignore this part and use the boundaries of integration from 0 to 1, then in this case it becomes 1 times arctangent 1 times arctangent 1 minus 1 over 2 ln 1, okay, ln 2, sorry, ln 2 plus minus for 0, we have 0 here, and we have also 0 here since ln1 is 0. So this is all. The answer is arctangent 1 minus 1 over 2 ln2, and we know that arctangent 1 is pi over 4 minus ln2 over 2. So it's all. If you prefer to convert the boundaries of integration, you may use, okay, I think it's enough for this problem. Let me show the second way in the next questions. Okay, let's look at this example. The integral from 2 to 4 arcsecant x arcsecant square root of x dx. Since inverse trigonometric functions come first, u becomes arcsecant square root of x, then du, if you differentiate both sides, du is equal to dx over 2x times square root of x minus 1. Okay, this is du. dv is the rest, which is of course dx. dv is the rest, then v is x. Okay, so let's use the formula of integration by parts. Then we have u times v, x arc secant square root of x minus v times du, x dx over 2x x minus 1 squared. Okay, then you may cancel these two terms, and this is equal to x. Of course, do not forget to write the boundaries of integration. Okay, then it becomes, okay, let me first solve this integral using substitution rule. We actually have minus square root of x minus 1. It's very easy to use to get the result using substitution rule from 2 to 4. Okay, then this integral becomes 4 times arcsecant 2 is equal to 4 times arcsecant 2 is pi over 3 minus 2 times arcsecant square root of 2 is equal to pi over 4, and if you put the boundaries of integration to this function, you have minus square root of 3 plus 1, and finally this is equal to 5 pi over 6 minus square root of 3 plus 1 as a result.